Okay, today we are learning something new, and these are called reference angles. And reference angles are going to be kind of important for what we learn about next week. We're going to combine those with special right triangles and a little bit of trig. But there are three things that need to be true for an angle to be a reference angle. The first is that it needs to be an acute angle, or if it's 90 degrees, it can be 90 degrees. But it needs to be 90 degrees or smaller. The second thing, most important probably, that gets missed the most, a reference angle needs to be formed by the x-axis and the terminal side of the angle. So when we draw these, you never draw a reference angle with the y-axis. You always draw it with the horizontal line, with the x-axis. And then the last thing is just that a reference angle has to be positive. So we're just going to do a couple of examples to find a reference angle. So the first one we're going to do is we are going to find a reference angle for 60 degrees. And all I'm going to do at first is I'm just going to draw a 60-degree angle. So I know that's between 0 and 90, so it's going to have a terminal side in the first quadrant. So my reference angle, I'm going to look at my rules. 60 degrees is acute. 60 degrees is formed by the terminal side of the angle and the x-axis, so I know that that is true. And then finally, 60 degrees is positive, which means this already fits all three of those criteria. So my reference angle is actually 60 degrees. I don't have to do any more work. Alright, so then, I can't erase the beginning question, we'll just move on. The next one we're going to do might be a little bit tougher. Okay, and you actually see what a reference angle is, maybe a little bit clearer now. We're going to find the reference angle for 130 degrees. Okay, so the first thing I'm going to do again is I'm going to draw a 130 degree angle. I know 130 is between 90 and 180, so my terminal side is going to be in quadrant 2. So there is my 130 degree angle. But 130 is not acute, so that doesn't follow the first rule of my reference angle. So what I need is an angle that has the same terminal side and the x-axis, which means what I'm looking for is the degree of this blue section that I'm coloring in right here. So I just need to determine how much that blue area is. Well, I already know that a straight line is 180 degrees, and I know that the terminal side of my angle is at 130. So in order to find that in between, all I have to do is subtract. So my reference angle here is 50 degrees. Okay, so now 50 degrees is positive, it's formed with the x-axis and the terminal side, and it is acute. So it follows all of those rules. So the reference angle for 130 is 50 degrees. Okay, now our next example is going to be a little bit tougher because it is in radians. But the only real difficult part about this is actually graphing the angle. So I first needed to figure out which quadrant 5 pi over 4 is going to be in. And there's a couple different ways you can do this. One is if you're comfortable, you can always convert it to degrees by multiplying by 180 over pi, like we did last week. All right, but another way to do it, if you're comfortable with fractions, you actually do it a little bit quicker, because I know that pi is at that point. I know where pi over 2 is, and I know where 3 pi over 2 is, and a full circle is 2 pi. So if I just think about this, I know 5 pi over 4 is bigger than 1. So that means that this angle is not going to be in quadrant 1 or quadrant 2, because it has to be more than 1. Then all I have to figure out from there is 5 pi over 4 closer to 1, which would put it in quadrant 3, or is it closer to 2, which would put it in quadrant 4? So since 5 pi over 4 is barely bigger than 4 pi over 4, I know that's going to be in this third quadrant. So here is 5 pi over 4. Again, if you're not comfortable with fractions or trying to figure out what that is, you can always convert it back to degrees. But either way, this angle is going to end up in that third quadrant. So now I just have to follow those same rules again. I need to find the reference angle with the x-axis and the terminal side, which is this in-between part right here. So I know all the way around was 5 pi over 4, and I know at 180 was 4 pi over 4. So to find my reference angle, all I have to do is 5 pi over 4 minus 4 pi over 4, which, remember, with fractions, common denominator, I subtract across the top. All I have left was pi over 4. So my reference angle for 5 pi over 4 is simply pi over 4. Now, one thing you might have noticed when we were trying to find these reference angles is actually there are some general rules that we can use. Now, it's not a good idea just to memorize these. It's going to be actually a lot easier for you if you look at the picture and just try to figure out what you need to do to determine that reference angle. But if you saw this, what you realize is that in quadrant 1, your reference angle is always just the same thing as your original angle if it's a quadrant 1 angle. Alright, if your angle was in quadrant 2, in order to find my reference angle, if I was in degrees, I had to do 180 minus that angle. Or in radians, I would have to do pi minus that angle. Now in general, you're going to see theta referred to a lot for angles and x referred to a lot for those radian values. You might see them interchanged, but I'm going to write it this way for now. Alright, now if you were in quadrant 3, your reference angle, you noticed it was similar, I still subtracted, but instead theta was bigger than 180. So I did theta minus 180. Or I did x minus pi. And then finally, in quadrant 4, I was close to going a full circle. So to find my reference angle, what I needed to do was 360 minus theta, or the equivalent of 360 in radians would be 2 pi minus my angle. Okay, so my last example, I'm going to look at another radian one because I know these are a little bit tougher, and I need to try to figure out the reference angle for 13 pi over 8. So what I'm going to do is, the first thing I'm going to do is figure out which quadrant this angle is going to have its terminal side in. So I'm going to mark what I know. This is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. And to make this a little simpler, I'm just going to write these with that common denominator of pi over 8, which would make this 8 pi over 8. Okay, I'd multiply by 4 here, so this would be 12 pi over 8, and then this would be 16 pi over 8. So I'm just getting a common denominator, so these all look the same. And I skipped this first one. This first one would be 4 pi over 8. So again, these are just my common denominators, so I can figure out which side of these 13 pi over 8 is closest to. So I know 13 pi over 8 has to be bigger than 8 pi over 8, and it's bigger than 12 pi over 8. So 13 pi over 8 is in between 12, and it's in between 16, which means my terminal side here is going to be in quadrant 4. So that means my angle, 13 pi over 8, would be right here. So the reference angle, again, I'm looking for this in-between spot here. So I know the terminal side was 13 pi over 8, and all the way around is 16 pi over 8. So again, all I need to do is subtract the difference. So I'm going to do 16 pi over 8 minus 13 pi over 8, and I get a reference angle of 3 pi over 8. So while you guys were working on these, you might have noticed a few patterns. So every time I draw my reference angle in quadrant 1, okay, my reference angle was just the same thing as my original angle, and I'm just going to call that theta. So my reference angle was always just theta. There was no work that needed to do when it was a quadrant 1 angle. When it was in quadrant 2, if it was my reference angle, I had to do 180 minus theta. And then if that was in radians, instead of 180, I would have had to have used pi. So pi minus. And instead of theta, I'm going to write x. Sometimes you'll see theta for degrees and x for your radian values. So that's the way I'm going to write them on here. In quadrant 3, my reference angle, I had to subtract again, but this time theta was bigger than 180. So it was theta minus 180. Or when it was in radians, it was x minus pi. Then finally in quadrant 4, my reference angle was 360 minus theta, or 2 pi minus x. Now you don't need to memorize these rules. It's going to be a lot easier if you probably just draw the picture and figure it out from there. But again, this is just some patterns that you guys have probably seen as you've been doing these. And that's all there is for reference angles.